wrong. So don't look at this as like bad. Look at this as like, oh, I've not quite communicated to Python the way I want to communicate. There's a way to solve this. There's a way to do something here. And so if we take Python and we think about Python and say, hey, you're so picky and you blow up if I do the least little mistake on types, like help me out here. And so it turns out that Python has a built-in function called type. So again, it's type with parentheses. Function calls have parentheses on them, and we pass something in. And we're like, hey, Python, tell me what the type of the variable EE is. And then Python prints out, oh, it's a string. What is the type of the constant, quote, hello, quote? That's a string. What is the type of the constant 1? That would be an integer. And so Python keeps track of the value of variables and constants, the value and the type of it. And so we have to kind of manipulate this and be aware of this as we move forward. And so there's several types of numbers that we've already sort of been implicitly playing with. Like I said, you can give a variable to type, or you can give a constant to type. Variables and constants that don't have decimal places are integers, what are called integers, and variables that have decimal places are called floating points. Even if this was a 98.0, it would still be a floating point. As soon as you put the point there, then that means it's a floating point. They are represented internally differently. Floating point numbers have a greater range than integer numbers, but they are not always as precise as integer numbers. So floating point numbers have more range and less precision. So integers are perfect, but there's a limit, like 4 billion or 4 trillion or something. There's a limit. Don't worry too much about that. There is a choice that you make. You tend to use floating point numbers for things like temperatures or speed. Turns out that you don't use floating point for money. You don't use it for money, even though in our first examples we'll be bad and we'll use it for money. But shh, don't tell anybody that I'm using floating point for money. If you want, you can play with floating point and start finding some things where money goes bad. Okay, there's actually a number of different movie plots that have to do with computer programs that use floating point for money. I think Office Space is one of them that I particularly like, but there's other ones as well. Why you don't use floating point for money. I kind of got off track on that, but that's okay. So we also have a set of built-in functions that can convert from one type to another. There's float, there's int. And so float is a function. It again has parentheses. We pass in 99. So as this expression is being evaluated, it has to call float. It passes in 99, and then what comes back is 99.0, which is a floating point representation of the number 99. 99 and 99.0 are not the same. This is a floating point number. So when this addition happens, it produces 199.0. So that is a floating point 199.0. You are force converting by putting this, calling float, you are force converting that to a floating point number. If we look at like I is 42, we ask what type it is. Well, that I is an integer. We can take a variable and pass it into the float function and get back 42.0. That 42.0 comes back. And we say, what kind of thing is in F? Well, F is a float, right? So you can see how we're manipulating the type of things and controlling it. And anytime we get a little confused, we use the type function and say, hey, what's going on here? Why don't I understand what's going on here? Integer division is something that actually changed between Python 2 and Python 3. It's one of the bigger changes, the bigger non-upwards compatible changes between Python 2 and Python 3. And so this I'm just reviewing. There are some things that were different in Python 2. So 10 divided by 2, even though those are both integers, produces a floating point result. This doesn't make much difference if these are evenly divisible, but if they're not evenly divisible, it makes a big difference. So 9 over 2 is 4.5. Think about like if you put in 9 divided by 2 in a calculator, you wouldn't expect it to say 4. And in Python 2, it said 4. It actually truncated. It actually threw this bit away. But in Python 3, it just automatically converts divisions to floating point, and so it works out quite nice. Okay, so 9 over 2 is 4.5. In Python 2, this used to be 4. And then 99 over 100 is 0.99, exactly what you'd expect in Python 3. In Python 2, that was a 0. Why? Because it truncated. It didn't even round the numbers. It chopped them off. So this was really quite a silly artifact of Python 2. In Python 2, if you get stuck in Python 2, you just use floating point numbers. And once either side of the division or any other operation is a floating point number, then the calculation is done in floating point. So if it's floating point input on either side, then it's floating point output. And this is what we used to have to do kind of in Python 2, is force things to be floating if we're doing divisions. It wouldn't hurt to do it in Python 3, but now integer division in Python 3 makes a lot more sense, thank heaven. Okay, string conversions. So if we read data, which we're going to see in a second, from the outside world, it comes in as strings. Whether reading from a network or from a database, we tend to get these things as strings. And so what we're showing here is a string value that's 123, but it's not really 123. It's 3 characters. It might as well be A, B, C. So 1, 2, 3 are the first 3 characters. So we take this string constant, we put it in there, and we say, okay, what kind of thing is in there? It's a string. And if we try to add 1 to it, as we saw before, you add a string and an integer, and Python gets really unhappy. Can't convert int object to string implicitly. But what if we know that inside of this string are actually digits, and we want to get an integer representation or a floating point representation of that? Well, in that case, we can call the int function or the float function, passing in a string and getting back an integer. So this basically reads these characters, the 1, 2, 3, and goes, oh, that's 123, and gives us back 123. And we say, what kind of thing is in there? Well, now in ival, there's an int. Now I'm being mnemonic here. I'm remembering that this is an integer and this is a string, but Python doesn't care what I name my variables. Remember, Python never cares about what I name my variables. So if I start naming them conveniently, don't all of a sudden think that everything that starts with the prefix I is an integer and everything that starts with the prefix S is a string. It'll be a number of lectures before I stop reminding you of that. So, ival ends up with an integer, the number 123, and now we can indeed add 1 to it because it's an integer, and Python's happy, and out comes a 124. So this works pretty well unless the string that in question has no digits. So there's no digits, it's going to blow up. It's like, whoa! Now, let's read it. Traceback means I quit. Where? Line 1. It's always line 1 because we're in this interactive environment. So, but if you were in a script, it would tell you what line it is. And then it says invalid literal for int with a base 10x. And that's like, okay, it's not working very well. And so, say, oh, that's an invalid literal. And again, we'll find ways to cope with this in later lectures. Okay? Now, how do we get data from the outside world? So this is the keyboard. Eventually we'll talk to networks and databases and files, but right now we want to take the keys from the keyboard and get it into a variable. So we have another function, a special function, the input function. And when Python comes running in here, it starts the input function, and the parameter to the input function is what's called a prompt. It prints out, who are you, and then it waits. And then we type into the keyboard, Chuck, and then we hit the enter key, and then it takes this string right here, and then it puts it in this variable right here. It is a string. Even if I typed in 1, 2, 3, 4, it would be the string 1, 2, 3, 4, not 1,234. Okay? And so that is the way. And so this program at this point pauses until we type and we hit the enter key, and then it takes that line of input, including spaces, whatever I've typed, and puts it in that variable. And then the program continues. And in this case, it just prints out welcome, comma, and then the contents of the variable NAM. And in this case, this space right here that you see between welcome and Chuck, that is caused by this comma. So we mostly seen printing one thing, but you can have as many things as you want with commas in print, and every comma adds a space, and so it's kind of friendly. If you wanted to, you'd have to concatenate these things together to eliminate that space. But most commonly, you're printing out a list of things, you probably want spaces between it. Okay? So that's how we read input. Up next, we're going to combine all these things.